You wake up inside a universe that refuses to hold still, not in the poetic sense, in the precise, merciless sense. You reach for certainty the way a hand reaches for a railing in the dark, and what you find is not a railing, but a number, an estimate, a forecast, a careful confession that the world will not tell you what it is. It will only tell you what it might do. And even that answer comes with a strange price. The moment you demand clarity, you change what you asked about. Reality does not merely hide, it reshapes itself under interrogation. The most honest physics we have does not describe a stage with actors moving through space. It describes the bookkeeping of surprises. For centuries, the human mind demanded pictures. We wanted matter to be little stones, light to be a stream, motion to be a smooth path you could trace with your finger. When you drop a coin into a fountain, you can predict the arc. When you bounce a ball against a wall, you can imagine the collision. The classical world is a comfort because it allows a story. It tells you what happened, where it happened, and why it happened. It makes you feel that the universe is narratable, something a mind can read like a sentence. Quantum mechanics arrives like an eraser across that sentence. It does not say your pictures are slightly wrong. It says the demand for pictures was the mistake. Beneath the surface, where daily life pretends to be solid, the universe is not built from tiny objects carrying properties like luggage. It is built from rules for predicting outcomes, and those rules do not require that anything possess a definite story in between. Imagine a beam of light aimed at a polished surface. In the ordinary world, reflection feels like a promise. The light hits, it bounces, it leaves at a tidy angle. You can sketch it, you can point at it, you can say with certainty where it went. But now begin to strip away the comforting scale. Consider sending the light not as a continuous wash, but as an individual event, one tiny packet, one arrival, one departure. At first, you might still keep the picture. A small thing comes in and a small thing ricochets away. Yet, as you narrow the experiment, as you refuse to allow a swarm and insist on one at a time, something shameful happens to that picture. The detections still paint a reflection pattern, but the pattern is built from singular punctures, like rain making a lake one drop at a time. Each particle seems to behave as though the wave were there, even when you have arranged the test so that only one is present. You try to salvage the story. Maybe the packet takes one path or another, and we just don't know which. So you build a situation where there are two possible routes from source to screen, like two corridors leading to the same exit. Classical logic insists that the packet must pick one. It must go left or right. It must have a history. But when the two routes are available, the final distribution of arrival points becomes striped and structured, as if something spread out and overlapped with itself. Then you block one route, and the stripes vanish, replaced by a different pattern that looks like a simple accumulation of independent hits. Nothing about the screen changed. Nothing about the source changed. Only the availability of an unused alternative changed the statistics of where the packet appears. The mind tries to speak and finds it has no words. How can an unused route affect an outcome if nothing traveled it? How can the world be sensitive to possibilities that never become facts? In the classical world, causes are physical events, collisions, pushes, fields, forces. In the quantum world, a cause can be an option, not an action, but an available action, not a thing, but a permitted thing. You can remove a path, and reality reorganizes its future. You did not touch the particle. You touched the space of what could have happened. At this point, the temptation is to accuse the universe of secrecy. Perhaps the particle does choose a route, but carries a hidden label, a private diary we cannot read. Perhaps the stripes come from unknown details. Perhaps reality is still classical underneath, only too fine-grained for our instruments. This is where the quantum viewpoint becomes genuinely unsettling, because it does not merely say, "we don't know yet." It says the insistence that there is a definite route is the thing that fails. The formalism, the cold procedure that predicts perfectly, does not ask which route the particle took. It does not reward the question. It replaces the question with a different one. What are the possible ways this detection event could occur? And how do those possibilities combine? And they do not combine like ordinary probabilities. Ordinary probabilities are the language of ignorance. A coin is either heads or tails. You just don't know which until you look. Ordinary probability adds alternatives like separate piles. If there are two independent ways for something to happen, you add their chances because each way contributes separately to the total. But quantum mechanics introduces a different kind of number, a calculation tool that behaves like probability only after you are finished with it. Before you turn it into a probability, it can cancel, it can reinforce, it can create a total outcome that is not the simple sum of the outcomes of its parts. These numbers are not little waves sloshing through space like water. They are not secret signals. They are not physical ripples you can bottle. They are instructions for prediction that refuse to become pictures. You assign one of these abstract contributions to each possible route the event could take. Then, instead of adding probabilities, you add these contributions first, like combining suggestions before you decide how likely the final answer is. Only after you combine them do you translate the result into the thing you can compare with data, the chance of the detector clicking at a particular point. This is the pivot where reality loses its familiar bones. Because if the correct procedure is to add possibilities, then nature is not selecting a single history and hiding it. Nature is letting multiple potential histories participate in the outcome. Not as parallel worlds you can visit, not as ghostly duplicate particles you could photograph, but as mathematical alternatives that carry influence. If you insist on an underlying narrative, you find yourself forced into stories that become grotesque. A particle that splits and merges. A packet that goes two ways but arrives as one. A photon that behaves like a cloud until it strikes, then behaves like a pebble. The quantum view does not forbid you from telling such stories. It simply refuses to guarantee that any of them correspond to what is actually happening. They are costumes we put on equations to soothe ourselves. So you decide to look. You try to watch the particle choose its path. You place a device at the corridor entrance. Not to interfere, you tell yourself, just to learn. But measurement in the quantum world is not a passive glance. To find out which route is taken, your apparatus must become entangled with that route. It must leave a trace somewhere in the world that could, in principle, be read. And that trace is precisely what ruins the delicate combination of possibilities. The stripes vanish. The structured interference dissolves into a plain distribution. It is as if the universe, when forced to speak in the language of facts, forgets how to answer in the language of overlapping maybes. This is not because the particle decides to behave differently when watched, as if it has stage fright. The deeper discomfort is that the act of making a fact, the act of forcing an unambiguous record into existence, changes the situation that the abstract prediction rules are applied to. When you ask which way, you have built a world in which way is a meaningful outcome. You have changed the set of alternatives that can combine. The mathematics adjusts, and the world follows it with indifferent obedience. You might try a compromise. Suppose you watch gently, softly, trying not to disturb. Suppose you build a device that only partially reveals which route, leaving the record faint. The pattern responds continuously, fading from striped to plain, as if the universe is negotiating with your demand for narrative. The more you insist on a definite history, the more the world becomes classical. The more you allow ambiguity, the more it behaves as though ambiguity is not a deficiency, but a resource. In the reflective world, light seems to bounce. In the interfering world, light behaves as though bouncing is an overconfident metaphor. A reflection can be described not as a tiny projectile reversing direction, but as the combined effect of many possible microscopic interactions within the material, each contributing an abstract element to the final probability. The polished surface is not a mirror because it knows geometry. It is a mirror because the combined contributions from the innumerable alternatives cancel everywhere, except along the path that looks like a neat bounce. The classical angle emerges not as a guiding rule, but as a leftover after everything else has annihilated itself. What you call the ray is not the path the light must take. It is the survivor of an arithmetic massacre. This is how the quantum viewpoint humiliates intuition. The world you can draw is not the foundation. It is the residue. It is what remains after the universe has done calculations too abstract for a brain to visualize. And still, even now, the mind tries to reach under the procedure and touch something solid. If the probability tool is not a physical wave, what is it? If it is only calculation, what is being calculated? The honest answer is that quantum mechanics does not settle that question. It offers a rule book that works. It offers a machine that outputs correct forecasts. It does not offer a mechanism you can hold in your hands. This is not a minor philosophical embarrassment. It is a structural wound in how we think. Human understanding usually means building an inner model, a picture that can be simulated mentally. We call that explaining. In quantum physics, explanation is replaced by a technique. You list the possible processes, you assign contributions, you combine them, and you obtain probabilities that match experiments with an accuracy that becomes almost insulting. The universe is not merely predictable. It is precisely predictable by a method that refuses to tell you what is happening between the source and the click. There is a certain kind of terror in a world that cannot be narrated, not because it is chaotic, but because it is indifferent to stories. The quantum rules behave as though reality is not a sequence of events, but a calculation whose final output is a set of frequencies. The world does not feel compelled to choose a single route until a record forces it, and when it does choose, it does not choose like a traveler. It chooses like an outcome. At a human scale, we live as though objects possess attributes independent of us: position, speed, color, solidity. Quantum mechanics teaches that many attributes are not merely unknown before measurement. They are not even the right kind of thing to assume exists. The theory does not say the particle has a hidden position and we are clumsy. It says that the particle is described by a spread of potentialities and that asking for a single position is an act that reshapes those potentialities into a fact. The past you can tell afterward is not a recovered secret. It is a new story consistent with the record you created. If that sounds like a trick of language, go back to the image. A screen in darkness, waiting. You fire one photon. A single point appears. A tiny scar of certainty. Then another and another. The pattern emerges slowly, not because the photons are cooperating, but because the rules governing their distribution are stable. Each dot is final. The pattern is statistical. The world is built from absolute events arranged by a law that speaks only in chance. You might think chance means ignorance, but here, chance is the final product. The quantum rules do not predict which dot you will get next, only the distribution that will arise over many trials. They predict flawlessly what can be predicted, and they refuse everything else. It is like being given a perfect map of climates while being denied the ability to forecast tomorrow's single gust of wind. In this worldview, it becomes dangerous to say, The particle went through the left corridor. It becomes dangerous to say, the photon reflected off that point. These sentences feel harmless, but they smuggle in classical assumptions that the particle has a trajectory, that the photon has a localized collision, that events unfold as a chain of causes with a definite middle. Quantum mechanics can often let you use such language pragmatically, as long as you remember it is a convenience. The moment you insist the convenience is the truth, the universe punishes you with contradictions. The punishment is subtle. It is not that the theory breaks. It is that your picture stops matching what you can test. You can keep the picture if you accept that it will mislead you in the cases that matter, or you can abandon the picture and keep the predictions. Quantum mechanics asks you to choose between comfort and accuracy, and it has no sympathy for the comfort. There is a quiet moment in every honest encounter with this subject when you feel the old instinct to make sense begin to exhaust itself. If you've made it this far, consider staying with that discomfort a little longer, the way you might linger in a dark room to let your eyes adjust. Because the deeper you go, the more the universe feels less like a machine and more like a rule. Not a rule written into matter, but a rule that matter seems to obey, even when the rule destroys the possibility of a simple underlying story. The outcome is not selected from reality's inventory of hidden facts. The outcome is built from the interference of alternatives that never become facts. Possibilities do not merely wait, they participate. And what about intention? The human mind loves intention. It loves to believe that something happens because something wanted it to happen, or at least because some mechanism pushed it there. In quantum mechanics, there is no sign of wanting. The particle does not decide. The photon does not hesitate. There is no hint of preference, no whisper of plan. There is only a structure, a method for generating probabilities. It is brutally impersonal. If you try to add personality, you will be misled because the theory does not need it. Even causality becomes less like a chain and more like an accounting of alternatives. In classical thinking, you tell a story. This caused that, which caused that. In quantum thinking, you consider multiple potential stories and combine them into a single prediction. The universe does not reveal which story was true. It reveals a distribution that behaves as though all allowable stories contributed. Causes become less like pushes and more like weights in an abstract sum. This is why physics at this level can feel like a discipline that predicts everything and explains nothing. It does not satisfy the ancient appetite for what is really happening. It replaces that appetite with a practice. Calculate the contributions, accept the outcome, and do not demand a picture that the world has not promised to provide. The unsettling part is not that we lack imagination. It is that imagination may be the wrong instrument. We evolved to survive among stones, fires, and predators. Our intuitive models are tuned to a scale where objects have surfaces and events have sequences. Quantum mechanics does not live at that scale. It lives where object and event are not primitive concepts, but emergent approximations, habits the universe permits once possibilities have already collapsed into the coarse certainty of everyday life. So when you ask what reality is, quantum mechanics answers with a silence filled by numbers. It answers by handing you a method that works so well it becomes humiliating, and then it watches you search for meaning where none is required. And perhaps that is the final discomfort, the suspicion that reality is not built to be understood, not in the human sense of understanding as a story you can tell yourself in the dark to feel safe. The universe may not contain a picture at all, only a rule that generates outcomes. We are the ones who demand images, the ones who crave a mechanism, the ones who want the comfort of a definite path through space. Quantum mechanics gives us something colder. It gives us a way to predict what will happen without granting us the right to say what is. It tells us that when you trace the world down to its deepest reliable description, you do not find tiny gears. You find a calculus of possibility. You find that the route not taken can shape the result. You find that the act of turning a question into a fact changes the landscape of answers. You find that certainty is not the default state of nature, but a special case produced when ambiguity is forced to die. And when the final dot appears on the screen, when the detector clicks and the event becomes irreversible, you are left with a universe that has delivered a fact without confessing a story. The calculation was right. The prediction was right. The method worked perfectly. It never had to explain itself. It does not care whether you feel satisfied. It does not care whether you can picture it. It does not care whether your mind can rest. It cares only that when you apply the procedure, the numbers line up with the world. And if that is what reality is, an engine of outcomes governed by abstract combination rather than narrative cause, then the most unsettling thought is not that the universe is strange, but that it is indifferent to being made familiar. You can spend your life trying to force it into a picture, and it will let you right up until the moment the picture matters. Then it will slip away again, leaving only the correct probabilities behind, like footprints that lead nowhere.